Hi class, so I had a request, my first request for an explanation video, so here it is. So what this is pre-lab question number 3 from the lab that we did last week, the first lab that we did, where we determined the number of grams of iron in those iron pills. And in the pre-lab questions, this is question number 3, and it says that using the data generated by following the procedure in the lab, so using the stoichiometry and the molarity of the potassium permanganate solution, you calculate that there is 3.028 times 10 to the minus 5th moles of iron 2+ in an average 10 milliliter sample of your stock solution, and we want to calculate how many milligrams of iron 2+ were present in a single tablet. So the cartoon that I've drawn here, I've got my 2 tablets, so it says note that you initially dissolve 2 tablets to make the 100 milliliter stock solution. So I've got 2 tablets going into my 100 milliliter stock. From that 100 milliliter stock, we took a 10 milliliter aliquot and we put that into our Erlenmeyer flask, and that's what we titrated. So in this question, we're starting out by saying, in this Erlenmeyer flask, I'm starting with 3.028 times 10 to the minus 5th moles of iron 2+. Now, one thing I sort of want to bring up and maybe mention is that definitely what I noticed in lab when we were doing these calculations at the end of class is we were just trying to get the calculations done, right? You were just sort of, is this the right answer? Does it seem right? Okay, good. Let's turn it in. We're done. Now, that's good, right? And we've got to get that done. We've got to turn those things in. But what we really should be doing is, rather than just trying to get the right answer, is being able to explain the procedure, explain all of this, communicate this on how we did the problem, how we know that this is the correct answer to someone else. And that's sort of the goal, and something that I'll try to work on with everyone as we move forward. So let's go ahead and solve this. We started from this 3.028 times 10 to the minus 5th moles of iron 2+, and I might sort of rewrite that and just do a little notation here. This is my moles of iron 2+, and that's the moles of iron 2+ in a 10 milliliter sample. Now, if I just look at my cartoon again, well, if I want to find the number of moles in my 100 milliliter sample, my 100 milliliter volumetric flask, I can see that I just need to multiply this number by 10. I'm going to have it's a 1 to 10 ratio, right? So I'm going to have 10 times the number of moles in my 100 milliliters of volumetric flask. So that's going to be 3.028 times 10 to the 4th, or 10 to the minus 4th, moles of iron 2+. And then what I'm going to do is I'm going to again notate what this value represents. This value is the number of moles iron 2+ in my 100 milliliter volumetric, right? A lot of the times we're going to end up having these values that are just sort of floating there, and we're not really going to remember what does that value represent. So as we're doing these problems in this class, when you get to a value, sort of put a little notation, remind yourself what that value represents. That's the number of moles of iron 2+ in the 100 milliliter volumetric flask. So if I want to find the number of moles of iron in a single tablet, I might, write, so therefore moles of iron 2+ in a single tablet, that's going to be 3.028 times 10 to the minus 4 moles of iron 2+ divided by 2, right? So I put 2 tablets into my 100 milliliters. So if I divide that number by 2, let's go ahead and do that. 3.028 minus 4 divided by 2 equals 1.514 times 10 to the minus 4 moles of iron 2+ in 1 tablet, right? So that value, right, again, I'm specifying what does that represent. That's my number of moles in 1 tablet, and I'm looking for, going back to my original question, the milligrams of iron 2+ in a single tablet, right? So to get to milligrams, I'm going to need to convert to grams. So if I take that value, 1.514 times 10 to the minus 4 moles of iron 2+ times 55.85 grams per 1 mole of iron, And here you can see on my calculator, I'm just taking that answer, right, because I want to carry those significant figures, and I'm multiplying that by 55.85. That's going to be my number of grams of iron, and I know that I want to convert that right away to milligrams, so I'm going to multiply that by 1,000. So I can write that in times 1,000 milligrams over 1 gram, so that my units will cancel nicely. That will give me my final answer in milligrams, and as we can see, 8.456 milligrams of iron 2+. We can do a quick significant figure check here. All of my values up here have 4 significant figures, so in my final answer, 4 significant figures should be appropriate. Hope that helps.